Good, welcome back. All right, let me open my R Studio and yes, please also open your R Studio in the meantime. Um, and correlation, causation. Here we are. Share. I think it's this one. Yes. And how is the size of my screen? Is it good enough? Should it be bigger or is it okay? Or maybe still. Oh, are we ready? Is my size all right? Yes, good. So I hope all of you have your RStudio open. If not, we can wait a couple of minutes. But today we are gonna go over, so now in the session we go over correlation and causation, what we saw from this morning. And I want to remind you that, of course, we are doing everything together now, so you will type alongside with me. But at the end of the day, I will point you to the repository on GitHub in which I put all the exercises and all what we saw yesterday. So, for example, there is here the one about the probability distribution and with all the codes, and these are all Quarto documents file that I think you already saw in the past days. So you can render it and it will render as a HTML file, and you can have all the codes and the explanation in one place. But I will give all of you this link at the end of the day because, again, I prefer let's code together first. And there's also a file with exercises that we didn't go through yesterday from the lectures from yesterday. You can do them anytime. There's like questions and also hidden answers, so you can compile your code and then see the answer after you do it. We can also see if today we end up early and there's something still unclear, we can go back to the topics of yesterday and today. So, as usual, first things first is to load our toolkit. And as we saw yesterday, my favorite package is the Tidyverse. It has inside ggplot, dplyr, and many, many others that we often use. So we just need to load this one most of the time. But today, as we said, we are gonna use a pre-compiled data set, so we're not gonna simulate our own data anymore. We will use data, real-life data. And since you're all social scientists, we will use a package called Gapminder. So you should have it because I should have checked, but it should be within base R, but I think so. So you shouldn't need to install it. But if you run this code and it tells you no package Gapminder, you will need to run install the package. Oops. Install the packages and then gapminder. Please let me know. I think this is not necessary. But yes, if you get an error message, this might be the cause. Once you all have your packages loaded, please thumbs and let me know that you are ready. In the meantime, I will put a header here to say that we are gonna do correlation and causation. Super. And I put my 4 minus, so I will have my beautiful header for later on. All right. We are ready. So usually, when we work with a new data set, even if it's our own data and we know what the columns are and what the data is, even then we would like to see maybe the data set. In this case, we never saw it. I assume we never saw this data set before. So what I would like to do is to have a glimpse. So just have a look at this data and what kind of columns it has and what kind of data it has. To do that, there is a function called glimpse in the dplyr. And it literally means get a glimpse of your data. In the past, print was used, but it was like, I find glimpse a bit more intuitive. So we can run glimpse and then say gapminder. This one. And if you run it, you can see that it's a data set that has 1,700 rows, 6 columns, and the columns are country, which is a factor. And as you can see, the country is repeated. So there's like many instances, and that's why it's a factor. So it groups all the categories that are the same altogether. And it goes alphabetically. So alphabetically, the first is Afghanistan. Then the other column is continent as well, is a factor. And you can see where does that country belongs to, which continent does it belong to. And for example, Afghanistan sits on Asia. Then there is year. It goes from 1952, I think, until 2007. And it's an integer, so no decimal numbers. Then there's life expectancy. It's a round number, so it's a decimal. This is another notation. Yesterday we saw it as numeric, but it could be also like written like this. Then there's population, so it's a fixed number, and then GDP per capita, which we saw before. All right. So why are there repeated countries in this case? Because for each row, there are several instances of year. So there is data for Afghanistan in 1952, and so it has this life expectancy, this population, and this GDP per capita in the year 1952. Then in the second row, there would be year 1957. It's always Afghanistan, and it has the new values. All right. Okay. So we already saw most of the things we want to investigate. So we need to know which variables are numerical. And in this case, we have year, we have population, we have like expectancy and GDP per capita. And which variables are categorical. In this case, we have country and continent. All right? All right. So now one of the first thing we might do is to visualize this data, all right? So, but all of this data is quite it's quite a big data set. It's 1,700 rows. It's quite a lot. So we might be maybe just interested in filtering it for year, for example. Just not to overload our first plot, let's say that we are interested in investigating only the data from 2007. So to do that, we can use a function from the tidyverse, which is the filter function. And I'm not sure if you guys already saw the tidyverse syntax, but if not, no worries, we go over it slowly. So I want to create a new data set called, oh no, I have it already. I have to hide it now. Well, anyway, I want to create a new data set, data 2007, right? This is my new data set. So I assign this and I take the original data set, gapminder, and then this is a notation for the tidyverse. It literally means and then. So every time I also teach the tidyverse to students, I always, like, if I have to say it loudly, I would say, okay, I create a new data set. I take the original data set and then I filter. Filter, which is again a function that filter as to a subset a data frame. So what it does is it takes the data set, the gapminder, and it filter it by a variable that I choose. In this case, I want to filter by year, and if the year is equal to 2007. All right? So if I run this will create a new data set that only has 142 observations that will be the one in which year is equal to 2007 only. Let's make another example, always with the filter before moving forward. Let's say, same thing, I want to create a data set of the year 1977. All right, so in this case, what would I do? It's the same principle. I would take the original data set and then, so by the way, to create this pipe, it's called pipe. To create it fast in RStudio, I always do Control Shift and M. Control plus Shift plus M. And this is how I create the pipe. So to create the data from 1977, how would I do? I would use the I can take a glimpse of data 1977. And as you can see, I have only one country now because it's filtered by year, so it's only 1 point per year, but for all the countries in all the continents. And the year is just repeated and it's always 1977. All right? We can use the filter function to filter for anything we want. Let's say, for example, we want to only see countries in Asia, right? How would we do that? We create a new variable called data Asia. We assign it. Yes, why two equal signs instead of one in filter? Yes, that notation is what tidyverse needs. So two equal signs means equal to. One equal sign will not be enough because one equal sign also in R is like to assign a value, right? Sometimes you say x equal 3. And if you run this, you have this new variable that is x. So one equal sign is just to assign a variable, and two equal sign means equal. Yes, thank you for asking. And it's also the same goes for the unequal sign. So to make, for example, if I want all the data except the year 1977, I would say filter in which the year is not 1977, right? So
Um,
all,
I can
yeah,
jump. Yeah, it kind of like locks in the year for your filter, the double equal sign. So by saying this, you're saying that you're looking at this data and you're locking in the year to be 2007, like you're filtering in for the year locked at 2007. So even
yeah,
if you look at the glimpse over here, like you have all the different countries, but the year is exactly 1977 for all your data points. And it
yeah.
has to be like that because the year is locked at 1977 for this particular data set.
Yes, that's another way to look at it. Exactly. Yes, yes. So let's say now, same principle before we go into the separate one. Let's say I want to filter all, I want a data set, sorry, I want a data set with all years except 2007, let's say. So I will call it all except 2007. I'm very bad at naming things, but this does the job. So what would we do in this case? We can't do, so we will take the gapminder and then one way would be to filter for everything that is equal to a certain number except the 2007. But this will take a lot of time and it will be very messy. What we can do is to filter for year that is not equal to 2007. So if we look at this now, this will have all the year up to 2002, but there's no 2007. All right. So this is the notation for unequal to. All right. Exactly. Not equal makes more sense. All right. Are there questions? We do another example now. Maybe not with year, but let's say I want a data set with only continent of Asia, or where continent is equal to Asia. How would we do that? Same principle. We take the gapminder and then we filter for not year anymore. Oops. Not year anymore, but we want to filter by the continent. Here, continent column. And continent has to be equal to, in this case, we need the quote marks because it's a text. So here, since it's a number, R understand this, but in this case, we need to put it in quotations, all right? So if I run this, we can do glimpse of data Asia. And if I run this, I will have all the years, all the countries, but only in Asia. All right? And as you can see, the number of rows has decreased because we filtered out everything that is not ASEAN, okay? Any questions? Are we good with this notation? Super. And if there's any question, please write in the chat or let me know. Also, if I need to go a bit slower, no problem. Okay, we said we want to plot. We want to make a plot now. What would we plot? We talked a lot before about GDP, GDP per capita, and life expectancy. So let's make a plot about that now. And we need to see first, how are those columns called? I could, from the glimpse, have a look. If we want to filter two things, yes, what do? It's very easy because the tidyverse really encourages you to just build up upon what you did. So let's say, give me an example. You want to filter by two conditions. Give me two conditions you want, and we do it together. From maybe two different columns, one from continent or country, and one from year. Yes, we can take two continents. So data, I call it AA, Asia and Africa. So we take Gapminder and then we filter in which continent, right? Continent is equal to Asia, comma, continent is equal to Africa. So you don't need to write another filter function. You can just stack them up. All right. You can also, from another column, exactly. Let's say we want the year to be 2007. And also the year to be 1952. There's nothing, by the way. We filtered it too much. Oh, wait, I think I wrote the wrong note. I wrote the wrong.
If we will write continent exactly equal to and combine the Asia and Africa, will it work? Can just try. Let's see. Like instead
So
of
wait, can you repeat the question?
like instead of writing in the filter twice continent exactly equal to Asia and then Africa, can we combine continent exactly equal to C and then inside Asia and Africa?
Yes, exactly. I think this is wrong. I wrote the wrong notation here actually because this
Maybe.
was within. Yes. So what exactly? You are right. You would do continent. Oops. Because in this case it will filter for everything that has the same that is either or, right? Yes. But in this case, okay, let's say it's from the same column. Continent, and then the notation would be in, oops, in with the two percentages. And then C, like Ajay said, exactly. And then we list them it would be Asia, and it would be Africa. Exactly. So as you can see, my notation before was wrong, and now it worked. And I have all the observations I need with all the different variables. Yes. Is this clear? I'm sorry, I did. So what I meant before, so another way to do it, and that's why I was confused, it was not the comma, is the same thing would be, so I put as in the same name, Gapminder, and then filter, and then continent equal Asia, or, so this is the notation for or, sorry, and, as or operator. Continent, and this would be continent equal Africa. If I run this, now it overwritten the one before, but yes, it's the same principle. So yes, I was wrong in the comma. You have to use this or operator. What does in function do? So the in, it literally, like in English, says like you take inside continent the ones that match this notation. So within the quotes, Asia and Africa. So the dollar sign does something different. The dollar sign selects the column within a data set. So for example, in this data Africa, Asia, if I use the dollar sign, it will show me the different columns within this data set, all right, data frame. And you can also see the sames are here. And you can see the same notation, right? This is data, and you have dollar sign country, which is the first column, dollar sign continent, which is the second column, etc., etc. All right?
And in coding, actually, there are multiple ways to get the similar results. It's
Yeah.
only whichever you remember at that particular time or which works for you. So there's not a single way to get the same result. And one student tried with this code, instead of in, if we write also double exactly equal to equals to,
That's what you meant. Exactly.
that worked. So
Yeah, let's put it, these codes do the same thing. Let's put it all together. Yeah, for example, this I didn't know. I never did it this way, but it's great to know. So Gapminder and then filter, continent, double equal sign, and then includes Asia, comma, Africa. This is my usual typing problems. Continent. Yes. Yeah. But in this case, I want to see because, for example, for me, these two do actually different things. Because if you can see it, maybe let's call it a two. It has a different set of observations, right? Between this one and this one. So the one I wrote here on top, this has 1,020 observations, while the second one has half of those, exactly half, right? What's the difference? if somebody wants to guess. Otherwise, we can. So this is like, it's quite tricky because what I think is happening, I will actually have to Google it later, but what I think is happening is that R is just like, how to say it? I think it's called recycling. Like it's taking, instead of checking if a row is either Asia or Africa, it checks the first to see if it's Asia, and it checks the second to see if it's Africa, and so on and so forth. So if the first row happens to be Africa, it gets filtered out. And if the second happens to be Asia, it gets filtered out. I think this is a bit complicated, but it's not so intuitive, but this would be not correct in this case because it will just, as you can see here, it just slashed our data set in half. So we lose important information in this case. So I will delete this just not to confuse. But yes, these two codes do the same thing. I think in my, again, you can use whichever you want. Usually I prefer to see it this way, but that's a personal preference, has nothing to do with anything. It's just because to me, for how I think, I like to see all the filtering in, in one way. So I can see at one glimpse, it's like, okay, I have filtered Asia and Africa, and then I can add as many other things as I need in this case, right? Why is not working? Filter confident. Let me see. I will paste it in my thingy. Unexpected symbol in. I think this pipe is not correct, but I cannot remember how it's written the other ways. Pipe operator. Let me Google it very quick because I always use this one. I know there is another way to write it, but I think I
Maybe
know it's.
the error is not because of that, maybe because of the slash, because the you use two slashes and here is only one. Just maybe
No, there's
no.
only one.
Okay.
Yeah.
Uh, because
Slash.
these pipe is just the symbols are different. They work similar way.
They do the same thing, right?
Yes.
That's
Yes.
something.
So that should
Yes.
not be a problem.
Yeah,
And
exactly. You cannot see the issue here.
you have one
We
extra bracket at the end, I think. In the new code, there is one extra bracket for
yes.
Africa.
Yes, there is an extra. You're right. Thank you
That's
so much.
okay. Yeah, that's okay.
Yeah, because here this bracket closes here and this is extra. So if you run it like this, it should work. Yes. Yeah, but I mean, this is totally normal. It happens to me all the time. As you can see, I couldn't see the problem. So this happens all the time. Just typos are, yeah. I don't want to say a necessity, but yeah, they happen all the time. So no worry. All right. So I think we need to move forward because this is about correlation and causation. If we want to go a bit more in deepness and the tidyverse, we have to do another session about that. So we were plotting, all right? We want to now plot the data from 2007, and we have the data set for it, and we want to plot the relationship between GDP per capita and life expectancy. All right. So we do it as we did it yesterday. We start with ggplot. We give it the data set, which is data 2007, and we give it the aesthetic of X. It's called GDP, and good that it gives me the suggestion here because I didn't remember how was it written, so I will just click here. and y is life something, life exp. All right. Put this a bit nicer, and I put a plus. For now, we just want to put points. So geom points, and we just plot it like it is. All right. So if we run this, you can see that there's a lot of points around. And yeah, we see as the same plot as we saw in the slides. All right. In R, you can already put the regression line. We will see it later, but just for you to know, you could already plot the line that R thinks is where the linear relationship lies between these two variables. All right? So to do that, we can add, geom is called smooth. If we look at it, it says aids the eye in seeing patterns in the presence of overplotting. Geomsmooth and StatSmooth are effectively aliases. Yeah, they both use the same arguments. Okay, so what it does is to just plot a line on where it assumes there is a relationship between the points, all right, between the two variables x and y. So we click on it, Geomsmooth, and we want to see a linear relationship, all right? We will see the regression later, but you already know what a linear relationship is. We saw it in the slides today. For example, in the sunny days and ice cream consumption, there was a line going up, and that was a positive correlation between the two. So to do that, we call a method that is called LM. So a linear relationship, linear model, but yeah, we will see it later. And we give it a color because, like, if we plot a line with all this a black line on all these black points is not going to be very visible, and we can make it blue or red or whatever you want. And we can run. What happens now is that based on the points and based on the fact that I asked them to just put a linear relationship, so a straight line, this is the best educated guess of the machine to where to put this line. All right? We cannot say if it's necessarily right because we can see that there's something off. Like not all the points fall around this line, so there is something off with this. But this is a great method to visualize. So when you have your data, you can put them in a scatter plot like this. And then you can say, okay, what if I try to fit a linear relationship between these two? Would it fit in this pattern? In this case, we can say no, not really, but yes, we needed to see this. So the red line in this case, the red line is a linear model. We will see it later, so now don't overthink about it, but it's just the average trend of this direction. And then you can notice that all the points here in the bottom left are very crowded, and then the relationship is actually should be a bit more curved, like this, right? This should be the correct line. But if we oversimplify this relationship, this will come up as this. Oops. As this. All right. So what we can do now is to calculate the Pearson coefficient. As you remember, we saw at Pearson this number between -1 and 1 that can tell us a bit more about the relationship between two variables. So to do that, we have to use the function core. It's called core. And if you have a look here, it says correlation. Compute the variance of X and the covariance and correlation of X and Y. All right? So what do we need to give it as input in this correlation? The two variables we want to investigate, right? So X and Y. In this case, we see a perfect example on how to use the $ operator because we need to put the column GDP per capita, right? GDP per capita, where is my sign here? Oh, GDP per capita and life expectancy. And we wanted to return a Pearson coefficient. And to do that, we need to tell them, okay, from the data set that it's called data 2007, take the column GDP per capita. And this will be our X, all right? And then from the same data set, take the column called life expectancy. So this would be core between X and Y, that our X and Y in our plot. If I run this, I get a number that is exactly our Pearson coefficient. This says 0.67, which means it's a positive number, so there is a positive correlation between these two variables. Note that I said correlation, not causation. I said correlation, so there is a positive trend of these two variables, all right? It's not perfect. A perfect correlation would be 1, but it's still positive. And it's not 1 because the data is messy and curved, and that's like real life situations. Yeah, exactly, from this data set. Yeah. All right, yes. Reminder, we are plotting only from the data of 2007. But let's do it again then. Let's try, because I think we have the data from 1977. We can do the same thing with that. So let's first plot it. ggplot. Actually, let me copy this whole thing. I can copy paste because it will be the same, exact same code. But I want to change this data set in data 1977. So let's see what will happen if we plot another year, all right? So the plot has different kind of points. As you can see here, life expectancy is lower, but somehow, oh wait, let me put some titles because I then get lost which one is which. So this one is from year 1977. And this one is from year 2007. So somehow the life expectancy in the 70s was overall higher because it, as you can see here, it like averages around 50, while in the 2007 was lower. But this could also be because maybe in 2007 we have more countries. Like maybe in the 77 there were some countries that were not reported in this data set. So could be a fluke, right? But the curve looks kind of the same. It has kind of the same direction. But we can see if they have the same Pearson coefficient. So to do that, we do core. We take this time the data from 1977 and the column GDP per capita. and we take the data from 1977 and the column life expectancy. Yeah, the result is quite similar. So the one before, let me run it again, this and this. There is a more positive relationship for the data of 2007 because this is closer to 1 than this is, but not by much. All right. You can try to do the same maybe with also different countries and see if the Pearson coefficient is similar or not. Yeah. All right. Questions about this? We have still 15 minutes. We can go and do maybe an exercise about this. So I want to know, I have a scenario again. I want to know the correlation, the Pearson coefficient of the relationship between GDP per capita and life expectancy in the country Afghanistan. So I will write it here. Oops, here. I want to know the Pearson coefficient for the relationship between life exp and GDP per cap in Afghanistan. So think about it a couple of minutes, and then, so how would you select, how would you filter the Gapminder data? How would you see the relationship first, and how would you check which one is the Pearson coefficient? Yeah, I will copy it. This one you mean? Yes, of course. Yes. So let me clean this up so it's more clearer. And I clean this up. All right. How would we proceed here? So we said we only want to see Afghanistan. So I will create a new, how to put the R value in the plot and the aggregation thing that you mentioned. Can we show multiple lines in a single plot? Yes, we can show multiple lines in a single plot. We can do that in a minute. And how to put the R value in the plot, like you mean in a text form, or like we can put it in a subtitle of the text, like in the labels of the plot or something like that. I think that would be That would be my answer, but yeah. All right, I see somebody put the code. I will copy it in my thingy. All right. We have data Africa. Well, let's do the example with Afghanistan, all right? I hope you don't mind, but we do Afghanistan. Why? Because we use a different column this time. So we take Gapminder, and then this is completely fine notation. We filter by Afghanistan, but what do I have to change also in this? Because Afghanistan is in the column called country. It's not a continent, it's in the column country. So we run this, and we have 12 observation for the country Afghanistan. Then we take this data set and we put it here. But before doing this, I would like to plot this, I think. But this is me, but I always like to plot things. But, well, we don't have to. Let's see the correlation. So it's slightly negative, but it's also quite close to zero, which again is our cutoff for no relationship. So it's slightly negative. So there is a negative relationship between wealth and life expectancy, which is a bit counterintuitive, but we can also say it's quite close to zero. So there could be that there's no correlation. All right. Let's do another one. Now, I think because of what the plots we saw before, I suspect that the link between wealth of a country and life expectancy might be different between the continents, right? Because of what we saw in the plots before. So let's compare two continents that have very far away history, let's say. Let's compare Europe and Africa. So the task now is calculate the correlation for Europe and compare it to the correlation with Africa. So think this code we can definitely keep that Dirash put, and we just need to add data Europe, in which we use Gapminder, and we filter by continent, Europe. I run both. Is it not Europe? That's what happens when you put only one equal sign. Yes, this worked. Yeah, thank you, Shiva. All right, and now what do we do? Core data Africa. I'm so bad. Data Africa. GDP. Data Africa. Life expectancy. And then core data Europe. No, I wrote Europa. Doesn't matter. GDP, data, Europe, life expectancy. Please put them in the same order. Don't flip them because the result would be different. All right. All right. So the result now tells a more compelling story, as in the relationship between wealth and life expectancy in Africa is less strong than the same relationship in Europe. Why can I say that? Because the Pearson coefficient in Africa is 0.4 and Europe has a higher or closer to 1 coefficient. All right? Now I have a question for you before we wrap it up. I want to know what could be a confounding variable in this relationship? Because we know that there is a relationship between wealth and health. But why then, if it would be the same everywhere, the same countries will have the same Pearson coefficient? So give me some example. What could be confounding variables that could affect this relationship? But beautiful. Health infrastructure. This is perfect. This could be a perfect confounding variable. Infrastructure, policy on health, information, yeah, anything in that direction. Yes. Super. Is everything clear except the tidyverse part? Because that was a bit messy, but it's not the focus of today. What is the interpretation of the comparison you just mentioned? A confounding could be stability, colonialism, yes, beautiful. Awareness regarding hygiene, beautiful confounding variables. Interpretation of the comparison you just mentioned. You mean the comparison between the data from different continents? To me, everything that we just said, like including these confounding variables, is a correct interpretation. So why do we look at Pearson coefficient, right? Or why do we look at the plots? Because real life data is never a perfect linear relationship between two variables. There's always something that is pushing this relationship in different directions. So this is a perfect example because the GDP per capita, so the wealth of a country, and the life expectancy in both of this scenario has the same directionality. Like we saw the directionality earlier today. So one influences the other, right? So one increases and the other one increases as well. So as I increase the wealth, I also increase health of the country, all right? But in these two different continents, the relationship between these two is not the same. So one continent for the same difference, for one difference in of 1 unit of wealth has a different response in health. All right. So this is a perfect example of like two variables that have different effects on something else. In this example is continents, but could be we can make another scenario of, for example, yesterday we talked about drugs. We test a drug and we find that in the global population, this drug has results in better sleep quality, all right? But then if we look into gender, we see that this drug has more effect on women than it has on men. It will be the same result that we would see here. One would have a Pearson coefficient that is higher, closer to 1, because the relationship is stronger between sleep quality and drug consumption. And in the other will be a bit lower, but the same direction will be in both. All right. It's important to do this because sometimes you generalize for the whole population and you don't see the actual picture. Can geographical climate? Yes, this could be a good point, but how would that affect wealth? I mean, I know that historically countries in the global south have lower wealth, but the relationship between temperature and wealth is a bit tricky to me. It could, though, climate could influence diseases. So we know that, of course, the more you go towards the tropics, the more diseases or different kind of diseases there are. So maybe that could be a confounding variable. I agree. But then you will need really to plot it out who is influencing what, right? Because in this case, could say that the climate temperature or being close to the tropic could influence life expectancy because of diseases or something like that. But I don't know if the same would apply for wealth in this case. But that's why it's great. It's good for debate, right? You could come up with a reason why you think that countries in the closer to the tropics are less wealthy. There could be some reason that now might escape me, and then you could have your null hypothesis that this is not the case, and then you would collect data, and then you would prove or disprove your hypothesis. This is a perfect example of a test. You start with a question like, can geographical climate of a region be influencing wealth and health? And then you do a test about it. Yes.
Uh, Yes, exactly. You mentioned that. And that's why we go through the literature review, which helps us, actually which variables to include. Because if you put any two variables together, there will be some sort of effect, definitely. But whether the effect is weak, moderate, or strong, and to save our time and energy, that's why we do the literature review and we find out actually which variables are going to helpful for us. Otherwise, it is an unending process. Which variable to
Yeah.
go with what? No?
Yes. And it also at the same time you have to be very careful not to add too many variables, right? Because it's true you have to be careful of like finding the variables that are confounding your relationship, but not to overdo it and put variables that have nothing to do, and then you think that might have a relationship, right? Um, I don't have an example on the top of my head now, but yeah, for example, in the sunny days and ice cream and shark attacks kind of triangle, right? Everything comes up to the summer, or the fact that you are close to the seaside. But it could also a completely unrelated something could happen, and you see a relationship, and that could be, I don't know.
It could be something like, for example, maybe fishing in that region. It's
Yeah,
completely unrelated, but
completely
it could be
unrelated.
that maybe, I don't know, there are more fishermen in that region and they're facing sharks on a daily basis, and that is not accounted for. But you're looking at variables on the beach side, on the seaside, you're looking at ice cream and
Yeah, exactly.
it's a shark attacks, but actually there's something else that is also playing a role. So, yeah,
But it
so
could be
there are lots.
playing a role, right? For example, the number of cats around the ice cream stalls. And you're like, yeah, but how does that correlate? Maybe it correlates to the fact that there is a lot of fishermen, and where there is fish, there is a cat begging for fish, but has absolutely nothing to do with the ice cream in this case, right? So don't overthink. Too many confounding variables can also be not what you're looking. Yes,
Yeah.
you always have to have a like clear picture, and yeah.
Yeah, yeah.
And like slightly more, if you want to go for more about the confounding variables, there is called as moderation and mediation. We can go for the topics of moderation and mediation. I think that more helpful for understanding better about the confounding variables. But right now we are not covering that. So yes. So are we okay for the longer break? We can go for the
Yeah.
lunch, right?
And
Sure.
yeah, and if there's some question, we can cover them
Yes,
later.
later on. So now we'll take a break for 60 minutes because students go
Okay.
for lunch and then we'll come back. Is it
Yeah,
okay?
in the office.
Okay.
Yes.
Okay. Thank
Okay.
you.
See you.
You want to say thank you? Say thank you, Kiara. Thank you. Okay. Bye bye.
Bye-bye.
Yeah. See, ma'am is there. Can you see? Ma'am, say hi. Say hi. Hi. She just came to invite us, come for the lunch. Man, yeah, we are coming for the lunch. Yes. Okay, then. See you after the break.